Hello and welcome to Nurture Academy. Today we are going to learn about how do you do the organic chemistry conversions. So usually we categorize the conversions into three different categories. First category is the conversions in which we are increasing the carbon chain length. So one of the method used for doing that is called Wood's reaction. The speciality of Wood's reaction is it will double the number of carbon from where you start. I have written here half of the example of Wood's reaction. So you take chloromethane. By default, whether they give you or they don't give you the another reagent, it will also be chloromethane only. So now when these two, they react with each other, we have to figure out what will be the product. In the presence of sodium, these two Cls will react to sodium and sodium chloride will leave, and this part and this part, I'll mark and tell this particular part and this particular part, they will join together and that will be the final product. So, which means is that if you start from chloromethane, you get ethane as a product of Wood's reaction. Okay, remember Wood's is used to double the carbon chain length, but sometimes they will give you some another type of starting material and end material. Let's see how you can apply the knowledge of Wood's reaction there. Now, supposingly, we are given the example of converting 2-chlorobutane to 3,4-dimethyl hexane. First task is we are supposed to draw the structure of 2-chlorobutane and 3,4-dimethyl hexane. Now, you notice one particular thing. Count the number of carbons in the starting material. 4. Count the number of carbons in the end product, that is 8. So think about the possibility of Wood's reaction. Now you will get confused because chlorine was given somewhere in the in-between position here, not in the corner. So what you do is you align the whole molecule in such a way so that chlorine points in one direction and this CH3 group we drew here. Rest with this carbon, we have one carbon, another carbon. So this is the carbon having chlorine. So we got another carbon, another carbon. Now after aligning, if you actually notice that this patch is exactly half of the final product. So you can use Wood's reaction for doing this type of conversion. Always when the final product contains double number of carbon than starting material, first thought should be Wood's reaction. Let's see next reaction for increasing the carbon chain length. We can also do variation of Wood's reaction. For example, if instead of a haloalkane, we have haloarine and we want to make biphenyl. In that case, we will start from chlorobenzene and then, as I told you the trick already, align the chlorine and this molecule, you double it and you get fitting reaction. For Wood's fitting, you take chlorobenzene and then you take methyl chloromethane. And here also, you will notice that this methyl group will go attach itself to benzene and we will get chlorobenzene. Another method of increasing the carbon chain length is using CN, nitrile group. We substitute it with any given halogen group and we can increase the carbon chain length by 1. Notice if you tend to get confused between Wood's and this one, you have to be very careful. Wood's specialty is doubling the carbon chain length. Here, the starting material contains 2 carbon and the product contains 3 carbon. So we are not converting 2 to 4, we are converting 2 carbon to 3 carbon. For these type of reactions, what we will do is, if you are starting from haloalkane, easiest pick is you substitute it with KCN. Why? Cn negative will substitute Cl negative, and now we got Cn. Basic idea is that if a side group contain carbon, then only it can increase the carbon chain length. Like this one, nitrile, it contain carbon. After that, we just will say that you do complete hydrolysis of nitrile group and you will convert it to carboxylic acid. Basic idea is that if you have haloalkane and you want to increase carbon chain length by 1, then you use nitrile because nitrile contain carbon in. Now supposingly somebody asks me to convert acetone to methyl propanol. The trouble is that starting material contain 1, 2, 3 carbon and final product contain 1, 2, 3 and 4 carbons. But the thing is that in this case, I cannot try with CN nitrile. Why? Because this compound contain a double bond and double bonded compounds, they have the tendency to undergo addition reaction, not substitution reaction. So now how we are going to go about with this kind of reactions. In this, we will use one very beautiful reagent. I want to increase only one carbon number. So I am going to take CH3 MgBr. In this, whenever MgBr is attached to any carbon, it is called, this whole compound is called Grignard reagent. The speciality of Grignard is, this is the only compound in organic chemistry where carbon polarity is negative and there is positive charge on the magnesium because magnesium is more electropositive than carbon. And now if you check the polarity of carbonyl group, carbon has positive charge and oxygen has negative charge. Double bonded compounds have the tendency to undergo addition reaction. So this CH3 will go here and MgBr will go here. Why? Because negative will go to positive and positive will go to negative. So if you try to write the product now, it will start from writing from this particular carbon. So CH3 you write as such. C, this double bond on addition will become single bond and MgBr will go to oxygen, right? This carbon will go here. Another, this particular carbon we will write as such. So this one on complete proton transfer will give you the required alcohol. So Grignard can also help you in increasing the carbon chain length. In fact, you can increase carbon chain length by 1, by 2, any particular group you can add, but the starting material has to be a carbonyl compound. Carbonyl compound means compound containing C double bond O, and you can convert it to alcohol. This is the way of increasing the carbon chain length. Apart from the classic methods we learned about increasing carbon chain length, we have two beautiful methods of increasing the carbon chain length on benzene. So one such method is called Friedel-Crafts alkylation reaction. In Friedel-Crafts alkylation reaction, we take benzene, we take CH3Cl in the presence of anhydrous AlCl3. The catch in this reaction is benzene can be attacked only by electrophile. So the combination of these two things is going to give us CH3 positive. That's why only CH3 positive will go and it will get attached to the benzene and we will get one carbon extra on the benzene. Second reaction is called Friedel-Crafts acylation reaction. So this group CH3 C double bond O. Actually, this is C double bond O. I'll expand and write. This group is called acyl group. Now, again, if you react it in the presence of anhydrous AlCl3, this whole group from here will have positive charge and it will go and attaches itself onto benzene to give you the final product. In this particular reaction, basically people make mistake is they don't know the end product name. So this compound is called acetophenone. Generally, if somebody asks you convert benzene to acetophenone, then people don't know the structure and then they tend to make mistakes. So please remember acetophenone is the name of this compound. Now let's see this classic reaction for again increasing the carbon chain length, doubling. Here people can get confused between Wood's reaction and this particular type of reaction. So children, remember, Wood's reaction requires the starting material to be a haloalkane. Here we have carbonyl group. Carbonyl group. So the play will be between the alpha carbons. This reaction is classic reaction called aldol condensation. It takes place between those molecules who contain alpha hydrogens. Now, what is alpha hydrogen? Alpha hydrogen is whatever carbonyl group is, you mark, like I marked with red color. Then carbon next to it, this one is called alpha carbon. And as many hydrogens are there on this carbon, these are called alpha hydrogen. Now, how do I write the product? It's actually very, very simple. One molecule you write as such. See how we align two molecules. So you align its carbonyl group in this direction and just write rest of it. Another also we are going to write ethanol, but this time we are going to align it so that its alpha carbon points towards this way. I've just written two molecules of ethanol only. First molecule carbonyl group and second molecule's alpha hydrogen is pointing towards each other. Now to write the product, what we are going to do is that this carbon which contain double bond O, this will get converted to OH. Let's see how. Rest of the molecule we will write as such. Now this was the carbon. So we will convert this double bond O into OH. Say OH. Okay. And then you start writing this carbon. Right now, don't fill the valencies. And then write this. All we need to do is we have to make carbon tetravalent at each and every point. Now, if you notice, whatever we got, this is called a product of aldol and this molecule. Okay. This still contain carbonyl group and this molecule contain OH instead of this carbonyl group. So this is classic method you have learned from small age. That is, if you have this like structure and if you have this like structure, what is the difference between these two? The difference is that this structure contain extra hydrogens. Sorry, this structure contain extra hydrogens than this structure. This contain only 2 hydrogens. This one contain 1, 2, 3 and 4 hydrogen. So basically, if somehow I add hydrogen into this, I will get alcohol. Adding hydrogen to carbonyl group will give you alcohol. Addition of hydrogen is called reduction reaction. So whatever we got here, if we do its reduction, then we can get the desired product. Basic idea is that if you have a carbonyl group, you are again doubling the number of carbons and you are ending up having diol, or you have a double bond and a OH group. Try for aldol condensation instead of thinking so much. So these are few methods of increasing the carbon chain length. In the next module, we will learn about some methods by which you can reduce the carbon chain length. And then in the third module, we will learn about some methods in which carbon number remain the same. So thank you so much for watching the video. Please tell in the description box which another type of videos you guys would like to watch and which topics. And if there is any feedback for which we can make the videos better, that is also welcome. Thank you so much for watching. Thank you.